So we need to find these dimensions here. This dimension here, remember, is going to be our length, and this is our width. So here's a right triangle. We know that this side, the adjacent side, is 1.5, and we're looking for the opposite side. So we're looking at a tangent of 32 degrees is going to equal that length over 1.5. So tangent 32 times 1.5 divided by 1. Gives us 0.937. So that's our length, 0.937. The width, then, we're going to be dealing with a tangent again. The width is the opposite side. The 1.5 is the adjacent side, so it's tangent 27 degrees equals that width over 1.5. And again, put the tangent over 1 and cross multiply and divide. So tangent of 27 times 1.5 divided by 1, 0.764. So what that means for us, since we actually were given that depth, instead of just having to put one in there to use, then what we're going to be finding here is an actual length of the cut. So here's our hole going like that. This dimension here is the 1.5. This is the 0.937. And this is the 0.764. So now how do we find the length of the cut? There you go. So 1.5 squared plus 0.937 squared plus 0.764 squared. Then all square rooted. So second square root, 1.5 squared plus 0.937 squared plus 0.764 squared. 1.927 inches. So that's our length. To find R, remember R is this angle right here, our rotation. R is the inverse tangent of this side over here, which is the 0.764, over this side over here, which is the 0.937. So 39.19 degrees. That's our angle of rotation. Our angle of tilt, that's this angle right up here. The angle of tilt, remember, is an inverse cosine of this height here, 1.5, over our length, this amount here, the 1.927. So second cosine, 1.5 divided by 1.927, giving us 38.88. So we've got our angles of rotation and tilt.
So what was the first length that you found?
The first lengths that I found, because I was not given, these offsets here, I was just given the thickness of the part and then the angles. This first length is just the offset in this direction. Normally I'm given length, width, and the thickness or the depth I had to find the length and the width of the box. So that length was this length of the box here, and then this width over here is the width of the box that way. Then I had the depth or the thickness of it. So yeah, what I was finding there is just the distance of the offsets from the angles. What we've been given before is we've been given the pictures look something like this. Where you were given this dimension and you were given this dimension. This time we had the angle, so we had to find those dimensions. Any questions? Ready for a quiz? Okay, let's do it. So the next step in all this that I want you guys to think about between now and tomorrow, I won't give you homework till tomorrow on it. What we're going to be looking at now is taking a block so like what we have been looking at, but now what we're going to be doing is we're going to take this block and we're going to set it up similar. We're going to rotate and tilt it, and what we're going to do is we're going to machine off the corner here. So the corner is going to get machined off to give us a surface.
What are we calling it?
This is going to be compound angular milling. So we're going to have to rotate and tilt it so that we can mill that surface. So this block has to be spun and tilted so that when we bring the mill down and mill that corner off, it gives us this desired surface. To make this work, if we're looking at it from above, we again have to rotate that piece. We're going to be rotating it such that this corner that we're milling off is perfectly vertical in our point of view here. So that's this edge right here that we're talking about from the top view. To rotate it that far, to figure out how far to rotate it, what we're looking at is if I blow up this little triangle here in the corner, that being a right angle, here's our triangle. What we have to do is we have to find this line across here that intersects that edge, this edge here, at a right angle and goes to that corner. So our angle of rotation is actually this angle right here, which will be the same as this angle right here. So either one of those can be thought of as our angle of rotation. Again, we're just looking at that from the top view. It's not on the surface itself. So if we're looking at it, what we're doing there, see if I can wireframe draw this in here. What we're finding is an angle right up here that's projected out to that corner where the corner used to be before we milled it off. Next, we have to find our angle of tilt. That angle of tilt is a little bit trickier to find. So obviously you probably on a mill won't be tilting the table, but we'll have some sort of a jig that tilts that block for us. We've got to tilt that block in such a way that that surface then ends up being flat and level. That angle of tilt is going to be, if I look at this from the side here, here's the surface being cut off. If we project out where it used to be, This top edge is actually this length that I just found here. This is our angle of tilt. So we're going to work on finding the pieces of that triangle. So I'm going to start out today by giving you dimensions that are cut out. Tomorrow we're going to look at what if it's not given dimensions, what if I give you angles that are cut out. So looking at that, if I look at it from the front, it's cut off like this. Yeah, I should move that down a little bit. Oops, come here. We'll just erase and start over. So I'm looking at it from the front, it looks like that. From the top, of course, we're cut across there. And then from the end here, from this end, we're looking at cut like this. So I need to give you this depth here. Then I need to give you this length and this width, which is going to be the same, of course, as this width. So depth, length, and that's our width. So if I give you that the depth of this is, oh, let's go 0.4 inches. The width here, 0.6 inches, and the length of 0.7 inches. I want to figure out how far we have to rotate this, and then how far we have to tilt it. To find our rotation, we're starting out on the top, this top view. In that top view, that triangle there, this triangle here, if I draw it out larger, this is the 0.6, this is 0.7. This is a right angle here. I need to cut it across here so that it forms a right angle, wherever that's going to come out.
Can you go up quick?
Yep.
Right there. The length is 0.7.
Yeah, this dimension right here is 0.7.
So the hypotenuse of that triangle is 0.6. Or the side.
This is the 0.6. 0.6 is this here. This is the 0.7. 0.7 is also here. 0.6 would also be there. Now looking at this, can't find out a whole lot about that unless I find one of these angles, either here or here. This angle here is going to be the same as this one here. So I'm going to find this one here. That angle, going back to the big green triangle, I have opposite and adjacent. So that's going to be an inverse tangent. Inverse tangent, the opposite side's the 0.7, the adjacent side's the 0.6. Gives us 49.40 degrees. That is my angle of rotation, 49.40 degrees. So that's how far I'd have to rotate that part to make that surface line up. Next, I need to find my angle of tilt. My angle of tilt's a little tougher to do. Once I've rotated this piece, what I want to look at, I'm looking at this from the side now. This being cut across here. I want to look at this triangle here. And what the top of the triangle, this piece is actually the piece that cuts across here. Because the piece is rotated now. So I need to find the length of that first. So I'm going to come back up here. That red line I drew in, I need to find the length of it. Well, I have this angle here, the 49.40 degrees, and I have this side. So if I just look at that triangle there, this is 49.40 degrees, and this is 0.7 inches. I'm looking for this side here. I have the adjacent and the hypotenuse now. That's going to be a cosine. So cosine of 49.40 is x over 0.7. Put that over 1, and I cross multiply and divide. Cosine 49.40 times 0.7 divided by 1. I get 0.456. So that's that distance across there. It's 0.456 inches. So that's the top side of that triangle. My angle of tilt is this angle right here. This side is the depth. That's going to be this dimension right here, the 0.4 inches that I was given. So to find that I have opposite and adjacent, that's going to be a tangent. It's an inverse tangent of the opposite side of 0.4 divided by the adjacent side of 0.456. That's from here. That was from this top view across here. Yep, the length of that. There is no real length of cut here because it's a surface, not a hole.
So what is that? What is that?
What that would be is if I was looking at this here, that 0.456 is that dimension found out here in red.
Why do you need that?
Why did I need that? Well, because what I'm trying to find now, if I draw this triangle in here, this is a right angle here, my angle of tilt is up here. So I have the 0.456 here. This is my depth of 0.4 that I was given. So that forms, if I pull that out, it forms that triangle like this. This is that 0.4 depth. This is the 0.456. That's my angle of tilt there. That triangle is kind of in a weird spot to be looking at. Here, let me see if I've got a block for that one. Yeah, I guess I do. So what we're looking at basically, this is where the corner would be on that block. If we tilt it, the angle of tilt is this angle formed right here. So that's what this triangle that we're looking at is that triangle formed by the two pens and the surface of the block here. So this is that depth we were given. This dimension is the one that was found across the triangle right here from the top view. Because what this is that's just looking at it from the top, looking at this triangle here from the top. So we found that diagonal dimension across there at the right angle to find that piece. It's hard to visualize, isn't it? That might would show it a little bit better if we could rotate the parts. Unfortunately, I don't have CAD on this computer, but maybe something I could request for future years to give it a shot. Okay, we will go over this more tomorrow. The next step is looking at this rather than being given these dimensions, is just being given you the angle of depression from each direction.
So we'll go down.
We're looking at that tomorrow.
What was the last?
I didn't ever actually punch that in to get that angle. Inverse tangent 0.4 over 0.456. Let's try that again. Inverse tangent 0.4. There it goes. 41.26 degrees.
So what all the answers would be required
What you would have here is you'd have an angle of rotation, the 49.40, then your angle of tilt here, your 41.26. Okay, it's close enough. We'll see you guys tomorrow.